Recrystallization is the process used to remove impurities from a solid compound. Throughout this video, the circles represent the solute, the squares represent the impurities, and the triangles represent the activated charcoal used to purify the compound. Safety aspects of this practical experiment. When handling boiling water, make sure to wear protective heat-resistant gloves. Make sure to read the MSDS for the impure compound being used. Under no circumstances should it be ingested, and vapors should not be inhaled. Safety glasses and laboratory coats should be worn at all times.
To begin the recrystallization process, find a suitable solvent for your chosen solute, one that the impure solute has low solubility to at low temperatures and is completely soluble at high temperature. Add the impure substance into a conical flask with a suitable solute in it. Place the conical flask on a heat source. Make sure to add boiling chips to prevent overheating and a more controlled boil of the solution. Once the solution has been fully dissolved, remove it from the heat source. Add a few spatulas of activated charcoal into the flask, making sure excess activated charcoal dissolves into the solution. Return the flask back to the heat source to commence boiling. Prepare another flask with 1 to 2 milliliters of solvent. Place a funnel with a piece of damp fluted filter paper into the same flask. Place the prepared flask onto the heat source. Pour the hot impure solution into the prepared flask of solvent, making sure that the solution does not recrystallize whilst filtering. If this does occur, wash the crystals with a small amount of boiling water. Remove the flask from the heat source and allow the flask to cool down to room temperature. Note that not all impurities would have been filtered, but make sure that the solution is clear. If the solution is pink, redo the filtration with more charcoal. Place the flask into an ice bath. Once you see crystals forming, take the flask out of the ice bath. Weigh the Buckner funnel filter paper and a watch glass. Record the mass. Attach the Buckner funnel to a vacuum flask, which should be attached to a vacuum filter. Ensure that the inlet and outlets are correctly attached. Put the Buckner filter paper into the Buckner funnel. Turn on the water source and begin pouring the solution into the Buckner funnel. Extract the crystals on the Buckner funnel filter paper from the Buckner funnel and place it onto a watch glass. Place the watch glass with the crystals into an oven at 80 degrees Celsius for 10 minutes. Take the watch glass out of the oven and weigh it. To calculate the weight of the crystals, subtract the mass of the Buckner funnel filter paper and the watch glass from the weight obtained.
This flowchart summarizes the steps involved in recrystallization. An impure compound is dissolved. The impurities must also be soluble in the solvent. To prepare a highly concentrated solution at a high temperature, the solution is cooled. A temperature decrease causes the solubility of the impurities and the substance in the solution being purified to decrease. The impure substances will crystallize in pure form because the impurities won't crystallize, therefore leaving the impurities behind in the solution. A filtration process must be used to separate the pure crystals at this point. This procedure can be repeated to purify the crystals more. To conclude, the slower the rate of cooling, the larger crystals are that form. The disadvantage of recrystallization is that it takes a long time. Also, it is very important that the proper solvent is used. This can only be determined by trial and error based on predictions and observations. The solution must be soluble at high temperatures and insoluble at low temperatures. The advantage of recrystallization is that when carried out correctly, it is a very effective way of obtaining a pure sample of some product or precipitate.